how can we make this a better model? Well, two-factor strong authentication. This is how people protect their remote access. But what is the value of certificates? Well, first of all, certificates are based on the concept of a public-private key pair. And this is used in what's called public key cryptography. And it's designed in such a way that the private key can be protected. It is never transmitted across any network. It is used in a cryptographic operation that allows for the distribution of a public key and the private use, the secure use of a private key, and the interaction can be validated in this model. So the key pair, when used in IPSec, is used to set up the initial encryption of the IPSec tunnel, what's called the phase 1 negotiation. Now, the group password, the shared secret, that's not necessarily used directly in setting up the encryption. It's used to validate that the user can connect and begin the authentication process. Whereas with certificates, because there's a strong cryptographic model associated with it, they are used. Now, the private key, as we distribute it into Windows systems, private key is marked non-exportable. This is not a portable authentication solution. So even if the profile were to leave the system, the certificate is not going to. So this is not a solution that can be easily picked up by somebody and dropped into other IPsec clients. Now, what are some other values of certificates? Well, in the model that SecureAuth uses, and you're going to see why I say we can do this, the IPsec client, if you're using a shared secret, chances are that you'll see security recommendations out there that say, for IPsec, you should roll that shared secret over at least every year. In PCI, they recommend that the maximum lifetime of a password be 90 days. So if you're going to distribute this second factor, the shared secret, that is part of the key to connecting to your network, you really should be finding a way to manage it. Very few organizations do, because it is so difficult to actually do this. You have two choices. Either you distribute a bunch of profiles and have people place them into the proper directory on their host system, or you create all new profiles and package them with the installer and distribute those, or, as is very common, you don't. You set up your profiles and you leave them there, often for many years. And one of the great values of certificates is that they expire. They have a lifetime, and that lifetime cannot be manipulated by the end user, by malicious software. They simply go away. This is your key control. Instead of having to rotate that shared secret, you can find a system that will allow you to maintain and manage the distribution of the certificates without an overwhelming administrative burden. Because certificates are not easy to distribute. You have a couple of choices in how you're going to go about that. You can have a manual end user process where they go someplace and they make a request for a certificate. It usually requires an administrator approval, so you've got help desk interaction or IT administrative interaction there, and then the end user has to return and complete the installation process using whichever tools are distributed, often just those that are within the operating system itself. And that certificate distribution process tends to only be secured by a username and a password. So it's not a model that you're likely to want to deploy on the internet. So from remote access, you cannot find a way to enroll from remote access with the level of security that you probably desire for your remote access architecture. In another model, they often require administrative initiation, so that before the end user can even get started, the administrator has to initiate it. So they have to go through and know who needs them, probably a request, a response, and then through the enrollment process, which still requires a back and forth of the administrator. Either that, or a lot of places, a lot of companies will say, wow, that's too much. That's too much for my end users. It's too much of their time, too much interaction, too much training. We'll simply have our administrative team, our IT team, do this for our end users. And it becomes an administratively intensive task that requires people and time to secure the network. Now, the SecureAuth solution. Multi-factor built an authentication solution that we found a beautiful way to integrate into Cisco's SSL VPN. A way to integrate an authentication model that requires a certificate plus a password, that provides for a very user-friendly, low administrative overhead enrollment model that is secure. And what we've done is we've extended that so that we can authenticate Cisco Secure Remote Access. We can take this out into your IPSec clients now with the same ease of use and the same reduced administration. In fact, we have even better tools now for the IPSec administration that were unavailable until now. So the SecureAuth solution is a user self-service certificate enrollment that requires strong authorization of the enrollment process. And we can do this through telephony, SMS, which are out of band, to a completely separate device than the user's enrolling from. We can use email or a postcard PIN, as some people like to call it, where a static PIN can be set up and snail mailed out to your users so that they can use that to authorize. There's no new database to administer. The SecureAuth model leverages any existing database. We'd like to talk about Active Directory because so many people are using that, and we simply tap into that LDAP. We leverage the existing data, the existing authentication. We have onboarding tools to get that PIN if it's not there, or the telephone number, SMS number. There's tools to get that information in there, and even provide user self-service for updates. Along with the low administrative overhead, it is a simple, click-through end-user experience that we've found requires very little support. Now, the SecureAuth enrollment process, this is what it looks like to the end user. They arrive at the front page of the authentication model. We like to deploy it with SSL VPN because there's a great model there. You can use it's basically a web service for enrollment, and it can be done that way as well if you choose not to use SSL VPN. But I think that we can introduce you to a model that will allow you to grow the use of that and use SSL VPN to further reduce administrative burdens and provide a excellent, easy, usable end-user experience. So we've got the simple user self-service model. They arrive. The strong authorization, you can see that a menu of authorization options is presented to the end user. They make a choice, and the registration code is then sent to them through that mechanism. They go through a process where on the client system, the SecureAuth software activates the generation of a public-private key pair. That private key is not distributed by any central site. It's generated on the client host system, and the private key never traverses the network. This is part of the power of the solution that we've designed, is that we have the client system enrolling. We're not just generating certificates and sending them out into the ether. And then at the end of the process, the user is notified that you're done. Congratulations. Now, this right here is not only how IPSec would look, it's also exactly how SSL VPN looks, and it's very similar to our web product as well. We use the same similar look and feel across our product lines.